streamline, integration of Euler's equation to obtain the Bernoulli equation, and assumption and limitations of Bernoulli equation. Okay, so these are the concepts which we are going to study in fluid dynamics, and after that we are going to study introduction to Navier-Stokes equation. It is just an introduction to you. Okay, we'll be getting the letter by Navier-Stokes equation just for our understanding. Okay, we are not deriving it, and we have something called as application of Bernoulli's theorem. So where we are applying this Bernoulli's theorem is in such as using venturi meter, orifice meter, rectangular and triangular notch pitot tube. Okay, so what is venturi meter, orifice meter, this notch and pitot tube? Why we are using this? What are these called as generally? Why we are using them? They are called as flow meters. They are called as flow meters. They are used to measure the discharge through a pipe. Okay, so for that we are using venturi meter, orifice meter, notches and pitot tube. Okay, so this is the general view of the fluid dynamics syllabus. Okay, so first, what is dynamics we have studied? It is the dynamics of fluid flow. It is the study of fluid motion with the forces causing the flow. As I have said, the kinematics is dealing with the motion of fluid. Okay, but we are only discussed about acceleration and velocity there. Okay, but here we are going to discuss about the forces which are causing that flow. The forces which are causing the flow, which are forces which are required for causing that flow. Okay. Okay. So dynamics is a bit different from kinematics in the terms of what? The flow motion. Fine. Give me a second. Okay. So dynamic behavior of the fluid flow is analyzed by
Sir,
the
one student is waiting, sir.
Okay.
Yeah.
Fine. Okay. So where were we? Okay. So the dynamics of fluid flow is different from kinematics, as kinematics is only for fluid in motion. Okay, it is considering only fluid in motion. It is not considering the forces which are causing that motion. Okay, like here we are considering only velocity and acceleration in fluid kinematics. But in dynamics of fluid flow or in fluid dynamics, we are studying the fluid motion with the forces that causing the flow. Forces that are causing the flow. Causing the flow means fluid is in motion. Fluid is undergoing a motion. So we are considering the forces over there. Okay. Now, the dynamic behavior of the fluid flow, whatever dynamic behavior of the fluid flow is analyzed by the Newton's second law of motion, which relate to the acceleration of the forces. So whatever dynamic behavior of the fluid flow is there, whatever we are going to study now, it completely depends on the Newton's second law of motion. Can anyone tell me what is Newton's second law of motion? Anyone of you?
Sir, force is equal to mass
Mass into?
acceleration.
Very good. So force is equal to mass into acceleration is what? Newton's second law of motion. So I've just generally given an equation for the Newton's second law of motion. That is, force is mass into acceleration. Okay. So this is gives the Newton's second law of motion. So here there is force. The force is the force which this force is acting on the fluid, whichever force it may be. It may be gravitational force, pressure force, viscous force, turbulent force, compressibility force. Or the m is what? Mass of the fluid. A is the acceleration of the fluid. Okay, in which direction? In any direction which is given over there. Okay, the fluid is assumed to be incompressible and non-viscous. What is meant by this? Anyone? What is meant by incompressible fluid?
Hello, sir. Sir, our student is
Yeah.
waiting, sir, to join, sir.
Okay. Hmm. What is incompressible and non-viscous fluid? What is incompressible and non-viscous fluid? What is the incompressible fluid? I have told you. You have studied the classification of fluid flow. In that classification, we have discussed about incompressible and compressible flow. What is incompressible fluid flow? Example? Can anyone give me an example for incompressible flow fluid? What is incompressible
Water.
fluid?
Sir,
Water.
its
Water is
density
an
will not change, sir.
density will not change. Okay, so that is water. And non-viscous means it is not having viscosity. It is having less viscosity, or we are saying non-viscous fluid. Okay. So for considering the dynamic forces acting on the fluid, we are assuming that the fluid should be incompressible and it should be non-viscous. So dynamics of fluid flow is nothing but it is the fluid motion with the forces causing the flow. In kinematics, we are not considering the forces, but in dynamics, we are considering the forces which are causing the flow and which is given by Newton's second law of motion, that is F equal to m into a. Okay, this is giving the force. Okay, this is the giving the force which is acting on the fluid. Okay, next. Okay, so equations of motion. So what it says that according to Newton's second law of motion, whatever the net force is acting, force F acting on a fluid element in the direction of x is equal to the mass of the fluid element multiplied by the acceleration A. So whatever we discussed in the previous slide is that the Newton's second law of motion states that F equal to m into A. So where m is the mass of the fluid element multiplied by the acceleration of the fluid in x direction. In x direction, if the fluid will be always flowing in one direction, it may flow in this direction, but whenever it is flowing, we are considering parallel to the pipe. Okay, if I consider like this, it is flowing in x direction for an example. Okay, so thus mathematically we are saying that force acting in x direction is equal to mass of the fluid into acceleration of the fluid in x direction. Okay, in terms of x direction, this is just an example. Always it doesn't flow in x direction. I'm giving you a direction in this. Okay, magnitude and direction both. Okay, see here. So force is equal to m into a into x. Based on this only, we are going to find out the forces which are acting on a fluid flow. So in the fluid flow, the following forces are present. In the fluid flow, the following forces are present. First one is gravity force. Do you agree that there will be a gravity force acting on the fluid when it is flowing? Anyone? Do you agree
Yes,
that
sir.
there will be some gravity force acting on the fluid when it is flowing, right? So if it is flowing in a river, okay, a river is flowing means it is flowing on the ground, touching the ground, right? It is not flowing in the air, right? So in the fluid flow, flowing following forces are present. Which one is first one is the gravity force. So gravity force is important because when it is flowing, there will be a downward force acting, and everyone in this earth on this earth is going through this gravity force. Okay. Next, the pressure force. Whether there will be a pressure force acting on the fluid when it is flowing, whether there will be some pressure force acting on the fluid when it is flowing. So whenever the fluid is flowing through a pipe, okay, the fluid is flowing like this, okay. So it will start creating a pressure on the pipe. If the pipe is full of water, okay, there is a water which is flowing through this pipe, okay, and this water is creating a pressure on the pipes through which it is flowing, right or no? Do you agree with this? So whenever the fluid is flowing through a fluid is flowing, it is creating a pressure force. Okay, force may be of different types. It doesn't mean that force is always one. Okay, It may be gravity force, pressure force, elastic force, tensile force, okay, viscous force, compressive force, turbulent force, compressibility force. Okay, if I say pressure force, what will be the formula? Just for your basics, what will be the formula for pressure force? Anyone? What is pressure? Anyone of you? What is pressure? What is pressure? Don't know?
External loads are applied.
It is force per unit area. Okay. What is this? Which force it is? Gravity force. Huh? Which force it is? Force acting
per
per
unit area.
force per unit area. Correct. I think. But which force it is? Gravity force. Huh? Viscous force. Huh?
Gravity force.
Very good. Pressure equal to force by area. So which force is this? Obviously pressure force, na? It is the force applied because of pressure, na? Right? So it is pressure force. So pressure force is given by what? Pressure into area. This I have already told you in your first module. Force due to pressure is force due to pressure is equal to pressure into area, not gravity force. Okay. So the pressure, it means that pressure may be a different type. Okay, it is not has to be only one force. Okay, it's sorry, force may be of different types. It is not to be. It is only one force. Okay, what are the different forces acting on a fluid flow? Gravity force, pressure force, viscous force, turbulence force, and compressibility force. So gravity force you understood. It is because of gravitation. Whenever the fluid is flowing, gravity is acting on it. The fluid is flowing through a pipe or somewhere. It is it is flowing. It is the pressure force is acting on it. Okay, fine. Then what is force due to viscosity? What is force due to viscosity? It is a viscous force. Every fluid has some resistance to flow. Okay, so this resistance is nothing but the resistance which is given to the flow motion. Okay, so it is not allowing the fluid to flow. That resistance is creating the resistance means what? It is creating a force, right? Creating a force on the different layers so that fluid doesn't flow in a smooth manner. Okay. For an example, honey. Honey is having more viscosity, so it flows very slowly. Compared to water, it is flowing very slowly. But water is flowing very fast, but it also has some viscosity. The lower viscosity fluid is air. Okay, air has less viscosity. Okay, understood. I have told you this during the in the first model in viscosity. Okay, next, force due to turbulence. Anyone? You have discussed about laminar and turbulent flow. What is laminar and turbulent flow? Anyone of you?
Laminar flow is straight flow, sir.
Streamline flow or laminar flow. It is flowing in layers. Okay, it is flowing in layers. Smooth flow. Okay, flowing in layers. If this is a fluid, okay, there is a pipe. Okay, there is a fluid. The fluid will be flowing. Layer will be flowing in this direction. There is no change in direction. It is flowing very smoothly. Okay, what is turbulent flow? What is turbulent flow? If the fluid molecules are flowing like this, if the fluid layer is flowing like this, you might have observed this when you are opening the tap at your home. Okay, sometimes it will be smooth. If the water is not there in your tank, you can see that when you open it will be going very smoothly. But when you increase the speed, okay, when you open up the valve completely or you open up the tap completely, what will happen? It will be flowing with a turbulence, right? If you want it to be smooth, what you will do, you will make it you will open it very partially. Okay, when you partially open it, it will be laminar flow. You might have observed it at home. So if the turbulence is there, it will be making a hish sound, right? You might have observed this. If it is flowing smoothly, it won't make any sound. You might have observed this at your home. If you're not observed, you can go and check your at your tap in your home using the taps. Okay, so that is force due to turbulence. There is a force which is acting because of turbulence also, turbulence in the fluid flow. There will be a turbulence in the fluid flow whenever you increase the or when you release the flow fluid with the higher velocity. Then force due to compressibility,
Force
F6.
due to change in density, sir.
It may be change in density or the fluid will be having more density. Therefore, there is a force acting because of compressibility or whatever we studied during the bulk modulus part. Okay, so this is the forces which are acting on the fluid when it is flowing. Okay, these are the forces which are acting when the fluid is in flowing. What is gravity force, pressure force, viscous force, turbulent force, and compressibility? Okay, so now we are going to substitute all these forces here, Fx. So this, whatever fluid is flowing, it is the summation of all these forces. Whatever fluid is flowing, Fx is nothing but the summation of Fg in x direction plus Fp in x direction plus Fv in x direction plus what? Ft in x direction plus Fc in x direction. So these are the forces which are acting in x direction, and this is the summation of all the forces. This affects the summation of all the forces which is acting on the fluid. Okay, that is here. So the sum, thus in equation Fx equal to ma, the net force acting. What is the net force acting? Fg of x, Fp plus Fv plus Ft plus Fc in the direction of x, direction of fluid flow in the direction of x. Okay, now, so this Fx is nothing but the net force, which is this Fx is nothing but the net force acting, that is gravity force, pressure force, viscosity force, turbulent force, and compressive force. Now, if we neglect, if we neglect, if we neglect compressibility flow, if we neglect compressibility flow, then the resulting net force will be what? The resulting net force will be Fg, Fp, Fv, and Ft. Therefore, when we neglect the compressibility force, okay, the equation will become like this. Okay, Fg plus Fp plus Fv plus Ft. So all, and this equation of motion is called as Reynolds equation of motion. This equation of motion is called as Reynolds equation of motion. So if we don't consider the compressible force, so it generally it means that these all are the forces which are acting on the fluid when it is flowing. Okay, so if I go on neglecting one by one forces, then we are getting a new equation of motion of the fluid. So that is when I take Fc out, then it will be Reynolds equation of motion. Now, for flow, where if I take the flow force due to turbulence, if I make it negligible, I'm not taking out, if I make it negligible, if I'm not considering it, negligible quantity of forces acting, like the turbulent force and compressible force are negligible, so it is not affecting the fluid motion. Okay, then the resulting equation is known as Navier-Stokes equation. The resulting equation is known as Navier-Stokes equation, which we are going to study in the further classes. There is just an introduction, not the derivation. Okay, so for flow where Ft is negligible, Ft and Fc actually, if both of these are negligible, then it is a Navier-Stokes equation. Now, what is the remaining force? What are the remaining forces? Fx equal to Fg plus Fp plus Fv. Okay, these are the remaining forces. Okay, if the flow is assumed to be ideal, what is meant by ideal? If the fluid is ideal means what? Ideal fluid means?
Incompressible and non-viscous.
What is meant by ideal fluid?
Which is incompressible and non-viscous.
You can say it is.
It is constant, not does not move.
It has no viscosity. A fluid which has no viscosity is called as an ideal fluid, right? A fluid which is having viscosity is called as a real fluid. A fluid which obeys Newton's law of viscosity and does not obey Newton's law of viscosity as a Newtonian fluid or and non-Newtonian fluid. So an ideal fluid is one which is having no viscosity. Okay. Therefore, viscous forces is zero. ये written यहाँ पे लिखा है ना कि viscous force is zero means it is an ideal fluid. When we are neglecting what turbulence force Fc and Ft and the viscous force, if we are considering an ideal fluid, then we are getting an equation of motion known as Euler's equation of motion. This Euler's equation of motion is obtained by considering the gravity force and the pressure force acting on the fluid. Okay, what we are going to study, what we have studied is, I'll repeat it again for you all. So this is the force acting on the fluid, force x equal to ma into x in the x direction. Okay, this is the net force. So this is not only one force, this is the group of or summation of all the forces which are acting on the fluid. Which are the different forces acting on the fluid? Gravity, pressure, viscosity, viscous force, turbulent force and compressibility. So this is the summation of all this. Okay, which is equal to, don't forget this, max. Okay, which is not necessary now. In the further part, while deriving this, it is useful. So max, okay, that is mass into acceleration in x direction. Okay. Now in this, if we go on neglecting Fc, okay, first if we neglect Fc, it will be a Reynolds equation. If we neglect Ft and Fc both, then it will be Navier-Stokes equation. If we consider this fluid to be ideal, where the viscous forces are zero, then we are left with what? Fx equal to Fg and Fp. So that is Euler's equation of motion, which is derived or which is considering only the forces which are gravity and pressure. Gravity force and pressure force are considered in this. Okay, understood? Any doubts? Okay. So now we'll be deriving the most important Euler's equation of motion, which has been asked every time in the question paper or in previous year question papers. Okay, so this is the most important question from the exam point of view. Okay, and the easiest derivation. Okay, and fluid mechanics, as you know, it is full of derivations itself. Okay, so what is Euler's equation of motion? I have told you, it is the fluid flow which is considering, it is the equation of motion which is considering only what? Forces due to gravity and pressure are taken into consideration. So equation of motion with the forces due to gravity and pressure are taken into consideration. This is derived by considering the motion of the fluid element along a streamline. So we are considering a streamline flow. Okay. So if you're, see here, we are considering a streamline flow like this. This is a streamline flow, this line. Okay. Upon which we are considering a cylindrical element. This is a cylindrical element. This is a cylindrical element. Wait. This is the fluid element, streamline flow. Okay. And we are considering a cylindrical fluid element in that. Cylindrical fluid element. It is not that it is a cylinder which is there in that. Okay. We are considering a cylindrical element in that. Cylindrical element of cross section area dA and length ds. Okay. So what we are going to derive? We are going to derive an Euler's equation of motion, which is considering the forces that are gravity and pressure force. Okay. This is derived by considering the fluid motion along a streamline. So this is the fluid motion along the streamline. Yes. Okay. Done. So consider a cylindrical element of cross section dA and length ds. So this is a cylindrical element which is having a cross section of dA. Okay, cross section means this area, whatever is there, this area is dA, and length ds. So this is the length of the cylinder, length ds. Okay, length ds. Okay, the pressure, the forces acting on the cylindrical element. What are the forces acting on the cylindrical element? Okay, that is, first one is the pressure force acting in the flow, direction of flow. This is the direction of flow. This is the direction of flow. So this, if we consider this to be cylindrical element, this is an area, and this pressure is acting on an area. Okay, so he is telling that pressure force it is. As I have told you previously that force due to pressure is what? Pressure into area. Okay, so pressure force is pressure into area. So pressure P is acting on the area dA. Okay, as I have told, the cross section is dA. So this, on this area it is acting, that is dA. The pressure force act PdA in the direction of the flow. So it means that, so the force is acting perpendicular to this area. Okay, to this area. Now the pressure force dou P by dou S into ds dA opposite to the direction of flow. So there will be, see, after the fluid has traveled a distance of ds from here to here, there is another force which is acting perpendicular to this cylindrical element. It won't be like this in this direction, but it will be opposite to it, because it is a imaginary fluid element, cylindrical fluid element, on which the force is acting. On which the force is acting. That force, the which force it is? Gravity force or pressure force? It is pressure force. So with that force is given by, this is the pressure into area. Pressure into area. So pressure force acting in the opposite to the direction of flow is P plus dou P by dou S into ds. That is the pressure into dA. Why dou P by dou S? Because the pressure has changed from this point to this point after traveling a distance of ds. Therefore, P plus dou P by dou S into ds into dA. That is the second pressure force which is acting opposite to the direction of flow, in this direction, and this is acting in this direction. Okay. Another is weight of the fluid element. There will be some weight of the fluid element. If there is no weight, then how there will be gravity? Do you agree? As I have said, we'll have considering gravity and pressure force, right? So gravity, if it is there, then W equal to M into G. When G is there, acceleration due to gravity is there, then weight has to be there. Therefore, weight of the fluid element or whatever fluid element is there, that is given by rho G dA ds. So that is shown like this. The weight is acting perpendicular to the ground. That is rho G dA ds. How we got this formula? Can anyone tell me? How you get rho G dA ds? How we get rho G dA ds? Any one of you? What is specific weight? Weight by volume. Okay. I want weight of the element. So what I'll do? Weight equal to specific weight into volume. What is specific weight? Rho into G. Everyone agrees? What is volume of this fluid element? dA, area, into length, ds. Therefore, weight of the fluid element is rho G dA ds. Is this right or wrong? Is this right or wrong? Is this right or wrong?
Right, sir.
Okay, these are the forces which are acting on this cylindrical element. Okay, I'm straight away telling you that this is not a cylindrical element which is there in the streamline flow. We are just considering a cylindrical fluid element of cross section area dA and ds. When this is the fluid flow direction, whatever this is, so that is the fluid flow direction, and we are just creating a cylindrical element surrounding it. Okay, so Okay, so this is the point. Next, let theta is the angle between the direction of flow and the line of action of the weight of the element. This is the direction of flow. This is the line of action of the weight acting on the ground. Okay, so that angle is given by theta. So we have shown the diagram over here. Okay, this is theta is like this. You can observe theta, ds and dz. Okay, ds and dz. So we have taken this as dz. Okay, now can anyone tell me which is the hypotenuse over here in this diagram? Which is the hypotenuse in this diagram? Which is the hypotenuse? Which is the base? ds is the hypotenuse, dz is the base, and opposite to that is perpendicular or opposite. Okay, fine. Now we have got all our forces. We have got all forces. One force is this, another force is opposite to the direction of the flow, another force is weight of the element. Do you agree that this is also a force? Weight of the fluid element is also a force which is acting on the cylindrical element. Yes or no? I have considered, see here, you read the sentence over here. The forces acting on the cylindrical element are pressure force dou P by dou S, this one, and weight of the element. So is this a force? Is this also a force which has to be considered on the cylindrical element? Anyone? Okay. We are considering this weight has also a force because weight unit is Newton and force unit is also Newton. Okay. So this is also a force which is acting in terms of gravity. Okay. Okay. So the resultant force on the fluid element in the direction of S must be equal to the mass of the fluid element into acceleration in the direction of S. So what it means is, so you see here, direction of S means what? The fluid is flowing in the direction of S. Previously, I have told you it is flowing in the direction of X. But here clearly I said that the fluid is flowing in the direction of S direction as shown in the figure. Okay, so this is the fluid which is flowing in the S direction, which is equal to the mass of the fluid element and acceleration in the direction of S, which is given by the Newton's second law of motion, and we have even discussed in the equation of motion. So what are the forces acting? How will be the equation here, the resultant force? What are the different forces? P dA plus minus P plus dou P by dou S ds into dA. Do you agree with this? Do you agree? Minus rho g dA ds cos theta. Okay, so we will see whether this equation is correct or no. Okay, so P dA minus P plus dou P by dou S into ds dA minus rho g dA ds cos theta equal to, these are the forces acting. This is the force, net force is equal to mass into acceleration. Mass into acceleration. Mass, how it will be mass? This is rho, density of the fluid into the volume. So density into volume is mass. Okay. So this is the equation 1. Now, here, this AS is the acceleration due to gravity. Acceleration due to gravity. So what is acceleration? Acceleration, it is the rate of change of velocity with respect to time, where this V is a function of S and T. V is what? Velocity. Velocity is distance upon or displacement upon time. So there is a displacement which is happening, okay, with respect to time. So this V is a function of S and T, A is a function of velocity and time. Okay, therefore we write it like this. dou v by dou s into ds by dt plus dou v by dt. So we are writing acceleration in terms of s in the direction of s as dou v by dou s into ds by dt plus dou v by dou t. Okay, therefore it will become v dou v by dou s plus dou v by dou t. Okay, therefore ds by dt is what? V. ds by dt is v. Since, see here, so v is what? ds by dt. So dou v by dou s into ds by dt. Dou v by dou s into v plus dou v by dou t equal to v dou v by dou s plus dou v by dou t. So what we have done is I have changed this to like this here. Dou v by dou s into ds by dt changed plus dou v by dou t. Okay, plus this dou v by dou s as remains as it is, but ds by dt is what? V. So v dou v by dou s plus dou v by dou t. Now, what is if we consider the flow to be steady? If we consider the flow to be steady, what is meant by this? Steady flow means what? What is meant by steady flow? What is meant by steady flow? Steady flow is nothing but which the property which does not change with respect to time. Okay, that is equal to 0. So if we consider that it is does not changing with respect to time, dou v by dou t is equal to 0. So this will become 0. So we get as equal to v dou v by dou s. This is our equation 2. Okay. Now we are going to substitute this equation 2 in equation 1 in terms of in form of as. Okay. So we are going to substitute the value, that is as equal to v dou v by dou s in equation 1. Substituting the as in equation 1 and simplifying the equation, we get what we get is here. So I have, if we take pda minus p into da plus minus dou p by dou s ds into da. What I have done, I have multiplied da here and da here. Okay, so it will be pda plus dou p by dou s into ds into da. Okay, pda minus pda will get cancelled. Minus what will remain? Minus dou p by dou s ds into da. Okay, same thing here. So I have done the simplification here. Minus dou p by dou s ds into da minus rho g dA ds cos theta equal to rho dA ds, that is this is mass, into what? Dou v by dou s. Okay, now dividing by rho ds dA throughout this. Okay, so what we get here? Minus dou p by dou s ds into dA will get cancelled. What will be minus dou p by rho ds minus g cos theta, because dA ds will go, rho will go, rho dA ds will go, remaining will be g cos theta equal to v dou v by dou s. Here there is v. Okay, there is v dou v by dou s. Fine. So now, so what we did is we have just shuffle the equations. So it will be dou p by rho ds plus g cos theta v dou v by dou s. I have taken everything here, then I made equal to 0. Now, so from the figure, this figure, what is cos theta? Cos theta is dz by ds, base upon hypotenuse. So dz by ds. Substitute the value of dz by ds in this cos theta. So it will be 1 by rho. I have taken 1 by rho outside. 1 by rho dou p by dou s, okay, or dp by ds, because it is partial differentiation, we can differentiate it. dp by ds plus g, what is this? Cos theta dz by ds plus v dv by ds. This is equal to 0. Or we can write it like dp by rho, okay, plus g dz plus v dv. Why? Because this ds is common everywhere in all the three terms. Okay, therefore we are multiplying it with 0. This will become 0. 0 into ds. So at the end, we are getting the equation as dp by rho plus g dz plus v dv equal to 0. This is our equation 3, which is the Euler's equation of motion. This is the Euler's equation of motion. But from this equation of motion, we have to derive Bernoulli's equation, so which will be your final equation. In exams, they will be asking you derive Bernoulli's equation from Euler's equation. So first, you have to derive this. Then from here, you have to go for deriving the Bernoulli's equation. So now, how we will derive the Bernoulli's equation is, so Bernoulli's equation from the Euler's equation of motion. So we are going to integrate this Euler's equation to obtain the Bernoulli's equation. Okay. So we are integrating dou p by rho plus g dz integration of vt equal to constant. So now, if the flow is incompressible, rho will remain constant. If the flow is incompressible, rho will remain constant. So we are taking rho out. So the integration of dp will be p plus g z plus v square by 2. Because v integration of v dv is integration of v with respect to dv is v square by 2. Okay. So now, what is the equation? P by rho g plus gz plus v square by 2. Okay. Or we can write it like this: P by rho g. We are dividing it with and multiplying it with g. We are dividing each and every term with g here. You can observe that. Okay. So what we should divide here? P by rho g plus z plus v square by 2g. So if I bring it to a form like this, that is p by rho g plus v square by 2g plus z equal to constant, then the equation 4 will be Bernoulli's equation. Then the equation 4 will be Bernoulli's equation. Okay. So now what I meant to say that is, if they ask you derive the Bernoulli's equation from Euler's equation, or if they just say that state Bernoulli's theorem and derive the Bernoulli's equation, many of the students will start from this and end it here itself. That is wrong. You have to start from the beginning, whatever we have discussed from here till here. So the derivation is complete till this point. Okay. Don't forget this. Still the derivation is not complete. So we are going to discuss what are these terms called as. What are these terms called as? This P by rho g is known as pressure head. P by rho g is known as pressure head. V square by 2g is known as kinetic head or velocity head. Z is known as potential head or data matter. Okay. So Bernoulli's equation from our equation we are here is P by rho g is what? Pressure energy per unit weight of fluid or pressure head. V square by 2g is kinetic energy per unit weight or kinetic head. Z is what? Potential energy per unit weight or potential head. Understood? So these are the terms. So this is the total energy equation from the all the terms. Can anyone tell me what is the unit for this equation? Can anyone tell me the unit? What shall be the unit for this? This derivation is important and from the exam point of view and the problems based on this. So can anyone tell me what is the unit for this? The unit is, the unit for pressure head is meter. The unit for kinetic head is meter. The potential head is meter. How? Pressure is Newton per meter square divided by rho is how much? Kg per meter cube into meter per second square. If you do all this, you will be getting meter at the end. Same for this, same for this. Okay. So the unit is meter. So this is the Bernoulli's equation which gives the total energy equation. So the total energy equation is the sum of pressure head, kinetic head and potential head. Okay. So what is the statement of Bernoulli's equation theorem? It states that in a steady flow, as we have taken this dv by ds as dv by dt as 0. So that is steady flow, and it is an ideal flow. We have assumed it of an incompressible fluid. The total energy at any point of the fluid is constant. So P by rho g plus V square by 2g plus Z is equal to constant. Therefore, the total energy at this is the total energy at any point is equal to constant. This total energy consists of what? Pressure energy, kinetic energy, and then potential energy Z, or also called as datum energy. Okay, this is the statement of Bernoulli's theorem. This is the statement of Bernoulli's theorem. So, what are the assumptions made while deriving the Bernoulli's equation? We have considered that the fluid is ideal. We have assumed that the fluid is ideal. We have assumed that the fluid is steady. We have even assumed that the flow is incompressible and the flow is irrotational. So, the important question from this may be that in exam they may ask like state the Bernoulli's theorem, make the assumptions which are made to derive the Bernoulli's equation, and derive the equation from the beginning, that is from the Euler's equation of motion. This question will be from 10 to 12 marks, okay, or 8 to 12 marks you can say. If they don't ask statement and all, they'll give 8 marks for the derivation. That too from I have told you have to consider it from the beginning, from the Euler's equation of motion. This derivation is very important from the exam point of view. Any doubts?